arithmetic operation. Arithmetic operation, pretty much straightforward. To add x plus, add, use the addition operator, add, subtraction, multiplication, division, modulus, exponentiation is power, and then floor or division. There's also a round, right? These are some operators that you can play with. X equals to 4, y equals to 7.6, print x4. Okay, so this is x and y. You can open a cell below by pressing B, highlight this B. So x plus y. X plus y, because x has a value, y has a value. Shift enter. I can just put a comma also, x minus y. I want x mod y. Yeah. Okay, so all you can do x mod y. So what it does, do you know what is mod? Modulus? Balance, divide, balance. Okay, so for example, let's say x equals to 8, y equals to 4. Okay, now no need okay, and then x mod y. What would be the answer? Yes, anyone? Yes, correct. Yeah, the answer is 0. X mod y means what is the balance? As 8 divided by 4, balance is 0. Answer is 2. Okay, so you can also x divide. This is division. X divided by 4. The first answer will be 0 because we're asking for balance. 8 mod 4 is balance 0, whereas 8 divided by 4 is 62. So this is what you get. Okay, and you see when you do division, automatically, even though the given number is a integer, the output is rather a float. It's converted to a float. Right. So another way of printing is using this f here. Just you put f here, and then the rest is the same. Use a quote sign and quote sign. But in between here, you see there's a brace. So for example, here I already declared x is 8 and y is 4. I can print this in a different way. For example, I just open up a new one, a new cell, print. Yeah. I put F, I put a quote sign. I can use single quote or double quote. I just want to use single quote. And then X is, so the braces would be as though like a command calling the value, right? And Y is, and then the brace again to command. It's a command where you can write a command. Y is a so for example, y is this. I want mode, and then x, let's say mode y. I want x mode y. Okay. So if you shift enter, you get to see nicely x is 8, y is 4. I want mode x is y, which is 0. Okay. So this is as though like you are writing your sentence at the same time you are running a code. You can run a code, or you just call the value of a particular variable or object. So it's a different way of printing. Just the front part here, you put F. Yeah. So this is yet another example for you. Okay, so I give you examples of addition, and then this is yet another way of addition. So rather than, for example, okay, never mind. Okay, so um, okay, I will open up a new for you. Okay, press B to open up a new cell. I'll copy this. I shift enter. And it doesn't say what is the answer, right? So basically, if you, I mean, it doesn't say what's the answer, right? So you want to know the answer, you just print X. Okay, so X is 34. Right, I mean X. We have been, I don't know, X. Now we lost track. What is X? Maybe I guess just give him Z. Okay, Z. Okay, Z is nothing now, right? Let's declare Z as 0, just to understand what is this plus equal sign means. Z is 0, and I'll change for Z equals to Z plus 2. Okay, so of course 0 plus 2 is 0 plus 2 is 2. So the answer we anticipate is Z is 2. Okay. So a new Z equals to old Z plus 2. That's what it means. Usually, rather than writing like this, I will copy C and I'll V duplicate the same thing. We write like that. Oops. Sorry. Plus equals 2. C2 also. So we, if amateur, they will write like this. A professional will be writing like this. It's the same thing actually, just like a shortcut. This means this Z plus equals to 2 means Z equals to Z plus 2. You can also put a star. Star means times. X equals to X times 3. That's what this thing means. But of course, when you run this, so you have to print it out, right? So you can just like open up a new cell, press B, print, okay, X, oops. Okay, so that's the value of X. Again, we lost track of what is X. We have been doing a lot of things on X. So this X is currently 108. Okay. Then I just explained about remainder. Then we have integer division, which is the output, just the integer. This is power. Y3 equals to Y squared 2. This is Y. Oh, this is square root. 0.5 is square root, right? For example, Z equals to 8. Oh, okay. Z equals to 25. Okay, then root equals to that power of 0.5 in the square root, right? So of course I did not print it. Print root. There you go. So 0.5 means 25 power of 0.5, which is of course square root, right? So we can also 25, but with 2 means of course power of 2. Yeah, it's too big. So there you go, power to 4. The power of 3 is 8, right? So, or you can straight away use power also, POW. Right? There's a function called power, POW. So if you like hover on top of the command POW, you get to see, oh, this is a power. Okay, power 2, power 3. You can also round. Sometimes like the number is too huge, you can round. So here I print so many, like I just give values and just print it out. You get to see each values. Okay, that's some sort of like a simple arithmetic. Here we have a special library called math. Which is a built-in, which comes with the package, Python package. No need for you to install. So for example, math, the square root, math of power, math of exponential, log, factorial, can check, is it an infinity sign or is it a nothing, N O N N S, actually not a number. Is it a not number? Not a number simply means, like, for example, you have a blank table, a table with the entry of blank, no, nothing, no value. Then it's a not a number. Pi, math.pi. Examples. So math, I just tried to be printing it, math.square root, math.power, and etc. You see? So of course, if you want to see one by one, you just like, okay. So first you got to import it, right? Otherwise, import math. Import math simply means that bring the math library in this Jupyter notebook file. Then you use it. Huh? Right, for example, I create a new one. Okay, import math. Okay, I use, let me use something else. Okay, absolute value. Okay, I use it here. So you get answer 4. Okay. So you can try one by one. See if you can do factorial. Yeah. Factorial of, I don't know what factorial. X becomes too huge. Okay, so let's try factorial. Open another one. Factorial of maybe 6. Okay, 720. There you go. Right. Okay, also can use round, right, to 3 decimal numbers. First, okay, let's print this, copy, print. What is the value? And what if I do round to 3 decimal numbers? What is X? Oh, X is too big. Maybe 4? That makes sense. Okay, so exponential of 4. This is the value. Very long, but we can do for 3 decimal numbers. That's the purpose of rounding. Okay. Again, so math.none, yeah, not a number. Well, you can check. Math is not. Is it not a number? Is X not a number? We already defined X is not a number. So you can check. The answer would be yes or no. Math is infinity. This X is infinity. Is it infinity? Of course it is. Okay, so true. If X is, let's say, math.pi, of course, is it infinity? Definitely no, so you get false. There are other shielding, other commands, built-in ones are math.shielding, math.floor, all this different way of rounding. We want to truncate, yeah, for examples. Shielding means it goes up, 0.2 goes up to 1. Floor means 0.2 goes down. We want to truncate just the first one, so 0. Okay, and then we have comparison operators. We want to compare 2 numbers. Logical operators, and or not. And then comparison operators, greater than, lesser than, equals to. This one is double, twice equals to. If it's single, you are giving a value, for example, x equals to 4. X equals 4 means you are checking, is it 4? So the answer would be yes or no, true or false. Okay, so the comparison, the output would be true or false. Logical operators also, the answer would be true or false. Okay, examples, x equals to 4. X print x equals not to, x is not equals to 0, which is true. X equals to 4, true. Greater than 5, false. Okay. Right, this is all, we do conditional statements later. We use it. So and then the logical operators to combine 2 comparison. statements, and, or, and not. Yeah. Okay. And then manipulating strings. We can also, okay, a string is just like a sequence. A string is just like sequence. Print S1. Okay, this is S1. S1 is a long, lengthy string. From 1 onwards. Okay, from 1 onwards. Okay, let's just take this. Okay, 1 onwards. See, the first one is missing. So what is the first one? The first one, the index would be 0. S1, what's the first thing? So first thing is T. What is the next thing? Next thing is H. So the bracket here is the index. The index always starts with 0. So T. Right, the last here, the last one is, we can start from here. This last one is here, -1. If you start from behind, far right, you start with -1. So G. We want to get N, -2 actually. Okay, -2 onwards. Is it? I say -2 onwards, which means N and G, right? String 1, 2, 3, 4, 5, 6. Okay, -6 onwards from behind, right? So get the last string, is it? So we can play around to manipulate strings. So again, string is actually just a sequence, like an array, a long array, and then to access in that array, we can use the bracket, and in the bracket would be the index number. For Python, the index number starts from 0, right? And then if you want to compute from behind, you put minus, okay? And then this double dot here, onwards, 1 onwards, -6 onwards, okay? So that's how we can play. We can also add, if you put add, concatenate, for example, okay, create a new one. A is string, B is a fish. Okay, print A plus B. So the plus sign here, yeah, the plus operator for a string is actually concatenation. Concatenation is put them together. A string fish. Let us put them together next to each other. Okay. So those are the things that we can do. And then of course the strings, they have a lot of functions, built-in functions. Right? The built-in functions can be accessed using a dot operator. For example, okay, I take this example again. I go down here. Okay, I'm going to print a dot. You see, when I put dot, there are so many functions available for it. Is whatever that is you're asking a question. Is it lower? It's lower. Of course, it's lower. All the strings are lower, right? Oh, sorry, it's lower. You have to put that. True. You have to put that. It's a function. Okay, let's make it upper. Let's make it upper. Uppercase, right? A dot U PPR upper string. It becomes this string becomes uppercase now. Right. So in order to access the functions available for string, we use a dot operator. Right. Again, I show you. Put a B, put an A. Okay, A. Oh, now B dot. When you put dot, whatever functions available for it, where you can see, you can choose. Okay. Of course, you can read about it. For example, join. What is join? Put a question mark. Shift enter. Then you can read about it. Or say, oh, these are the things. Blah blah blah. Okay. I think we call it a signature. So every function has a signature. Signature simply means an explanation how to use it. For example, they give you example. Join AB PQRS becomes AB.PQ.RS. Okay, that's what join does. You can always copy and run and see. Shift enter. Oops. Oops. There you go. Okay, so again, how did I go to the help file? Right. For example, a dot count. I don't know what it is. Just put a question mark. Shift enter. I say it's a built-in function, and on all occurs up. Sometimes you don't understand. But if they give examples, it's easy to figure out. You can always go and Google, and you get to know. Okay. Sometimes they give examples. For example, here to how to use for join, you get to do it. All right. Usually, count expected at least one argument. Okay, count 3. I don't know. I've never used this count before. Okay. But of course, you can always check, right? Okay. Here, more of comparison. So here we are comparing with two strings using a logical operator, comparison operator. Okay, so is it equals to, or greater than, or this one is just concatenating, putting them together. Shift enter, so we get to see the answers.